Hello and welcome back. Let's catch up with Rails 4. In the previous lesson we talked about caching. It was the last lesson on the topic of controllers and views. Today we're going to start a new chapter on the new features of Rails 4, and we'll start off with live streaming. Let's get started. In order to use live streaming, we'll need to perform some steps. The first one is to have a threaded server, something like Puma or Thin. The reason behind this is each live request demands a new thread so that it can run on its own without compromising the entire system. So that's why we need a server like Puma. That's the one we're going to use. In line 9, I'll add the gem Puma. Let's save and run bundle so that the gem is installed. I've already had the Puma gem installed, so this is the reference. Now that we have the Puma server, we're ready to start typing some code. First and most importantly, you need to allow concurrency in your application so that any server that you use can use threads to perform live streaming. So be sure to put config.preloadFrameworks and config.allowConcurrency both to true. We'll need to have a controller that works exclusively for live streaming. So we'll do that. I'll call bundle.exec Rails generate a controller. I'll call it, for example, stream for live streaming. It will have a single action for now called index. The controller is generated, and now we're ready to type some code inside. So let's go to stream controller, and here it is. We have the index action ready to be built. Before we jump into the action, we'll need to include a module in the controller. So include action controller, ;, and then live. This is a module that gets included in your controller so that it supports live streaming. It contains all the necessary instructions to support a never-ending connection. So this is crucial if you want to have a stream controller like this one. The next step is to declare a special header, which I'm going to paste. This header must be introduced so that it can correctly interact with the client. The client recognizes this kind of content type and behaves accordingly. After this header being sent, we're ready to type anything we want to the client. To write something to the stream, you simply call the response.stream.write method. Every response should have 2 new lines after each write, so that the event is sent to the client and it does something with it. But we're still not done yet. We'll need to close the stream every time we send a new request. So this works just fine. The next step after this is to create a JavaScript event source object that will point to this very action. So I'll go ahead and go to the assets folder, JavaScripts, and I'll directly go to application.js. I'll apply the jQuery ready function, and now we're ready to create that event source object. Let me explain to you what I'm doing here. I'm creating a new object of the event source type, and I'm passing a URL. That source object contains an onMessage property, which we'll assign to this function. This means that when this object is instantiated, it starts a connection with the server, which in turn is responsible for streaming content to the client, and all of the events are dispatched by the server. This onMessage method is responsible for handling the data that's triggered by the server. So let's go ahead and boot the server. I'll type bundle.exec Puma. Since we're using Puma, we need to invoke it specifically. Okay, so the Puma server is up, and now we can go to the browser and see what happens. In the browser, I already loaded the developer tools at the bottom, and I'll type localhost port 9292. You see that already we are receiving a first message. This is the first console log, and then the other ones are failing. Why is that? When we go to the console, we see an I/O error. That means the socket failed to transmit the data, and it threw the exception. We'll need to do something about that, and also we need to handle this exception so that your server won't break in production when someone simply decides to disconnect. The first thing we need to do is rescue the exception. So we'll do a begin block here, pass everything inside, Then we need to rescue the exception, and I'll type IO error in here so that all the disconnections are handled. And then we need to ensure that the stream is closed. You don't need to do anything inside the rescue block, but you should always close the streaming. Otherwise, the live streaming won't work. So this is taken care of. And now I'm going to the routes file, and instead of doing stream/index, I'll pass resources stream only the index section. This way we'll get /stream like we are requesting in the JavaScript. So this is taken care of as well. Let's go to the server and restart it. So bundle exec puma. Okay, it's running. And in the browser, opening the developer tools, I'm going to reach that server again. And there it is. We are receiving correctly all of the messages that we wanted. Every 2 seconds, we're receiving a new message. So that was the basics of live streaming. That's all there is to it. You create a new event source, had an event handler like this one, then you go to the controller, include the module, then you define a begin rescue block to capture all disconnections. The header of the content type must be set. You perform all the logic that you need, and then finally you ensure that the stream is closed correctly. Also in line 7, when you write something to the stream, you need to pass data, colon, you print whatever you want, and then you finish with double new lines. These are the basics, but we can do something a little better. Let's say, for example, that we want to pass some JSON data, something in these terms. Instead of simply printing the event, we can print its data and use it. In this case, we'll simply log whatever comes from the server. But remember that you can use this to whatever needs you have. So I'm going to save this, and then I'm going to update the stream controller method in order to print some JSON. I'll start by opening the object, adding a name, for example, index, and then I'll print the value. And finally, I'll close the object. We'll need to surround the key with double quotes, so I'll do something like this. And remember that we cannot replace these with double quotes because the new lines will not be parsed otherwise. So now we can save this. Let's not forget to open the server, so bundle exec puma. Now we can go to localhost 9292, and now let's go to the console and see that we have an object with the index being printed out to us. So right off the bat, you have the flexibility to pass not just strings, but also JSON objects. Let's do something else. Let's add different types of responses according to whatever situation it is we're trying to accomplish. Let's say, for example, that we want to force the client to close the connection upon some error. Let's say, for example, that at the end, we want to add a new kind of response. So response, stream write, and now we're going to pass a kind of event. So I'll pass event, and then the name of the event that we want. I'll type finished, for example, to tell the client that we're finished with the connection. Finally, I'll pass \n, but only a single one, so that I can pass some data along with the same stream. So data in here, and I could pass something like a termination message. There, with the double new lines and everything to terminate this particular message. To make things a little less boring, I'm going to switch from 2 seconds to 300 milliseconds, and instead of 10 times, I'm going to pass 5. That way we'll get a much faster response. In the browser, we'll go to localhost 9292 again, and you see that all of the 5 objects are being presented to us, many times as long as the connection stays alive. But we don't see anything regarding the termination message. To listen to the new event that we added, we need to add a new event listener for that particular event. I'll type source.addEventListener. This is standard for JavaScript in the browser. The first parameter of this method will be the name of the event. So finished it should be. And finally, I'll pass the event data in a callback. Let's do the exact same thing, and instead of parsing the JSON data, we'll simply print the string. So let's save and go back to the browser. Visiting the same page, you will see the 5 different objects and finally the termination message. Now we're able to recognize many different kinds of events through live streaming. This allows for greater flexibility on handling your stream data. There's one thing that we're still missing, and that is to kill the connection. Once we receive the finished event, we should close the connection on the client. So let's do that. After the finished event is triggered, we'll need to call source.close, like this. Let's save, go to the browser and reload. And now we're receiving the 5 times the object, and nothing else happens. So that's it for live streaming. It's one of the most anticipated new features to come to Rails 4, and everyone's really excited about it. Be sure to try it out, as it offers many new possibilities on real-time data transfer. I hope you have enjoyed the content today. In the next lesson, we'll take a look at turbolinks. I hope to see you there. Thanks for watching.